All right, Algebra 2 students, here is section 2.4. We're looking at writing equations of lines, okay? So for 2.2 and 2.3, we've been focusing on slope and graphing these guys. Now we're going to focus on trying to find the equations of lines using the information that is provided to us, okay? Before we do that, we're going to need to refresh on two other forms aside from slope-intercept form that you're familiar with already. You're probably familiar with these other two, but like I said, we're going to refresh on them. The first is the point-slope form of a linear equation. Okay, here it is. It's y minus y sub 1 equals m, which remember is our slope, times this entire quantity, x minus x sub 1. Where the line it creates, when you graph this equation, you can graph this, maybe not immediately, but if you simplify it to slope-intercept form, you could graph it. It has the slope m, and it crosses through the point x1 comma y1. So that kind of tells you a little bit about when we use point slope form. Whenever they give us the information of a slope and some other point, then we can use point slope form to go ahead and graph that line, or go ahead and find the equation of the line. Okay? And then, as I said, just as a reminder, slope-intercept form, that's our y equals mx plus b. Let's go ahead and do some examples. So example 1, we're going to go ahead and write the equation of the line given certain information. In part A, we're given the slope and the y-intercept. Now this one isn't going to be too bad at all because, if we're given the slope and the y-intercept, that's all about our slope-intercept form. That's what it's about. We need a slope and a y-intercept, and that is exactly what we're given. So we're literally directly going to plug it into our slope-intercept form since we have all the information we need. Y equals, our slope is m, negative 3/7. So negative 3/7 x plus our y-intercept, which in this case is 2, plus 2. Okay? That one was too easy, of course, because we were directly given the pieces of information. So let's definitely do a few more examples so you can get the hang of it. Part B passes through 0, negative 4, and has a slope of 1/2. Now go ahead and kind of think about this problem first. What exactly are we going to do? Are we going to use point slope form that we learned about above? Since, I kind of told you that for point slope form, we're going to need a point and a slope. Or can you think of another way that we can do this? Go ahead and pause the video and ask yourself, do I need to use point slope form here? Okay, if you said yes, then that's okay. If we use point slope form, we're not going to get the wrong answer, but we're doing more work than we need to. As mathematicians, we're all lazy, right? So I'll show you the shortcut, or not the shortcut, but I'll show you the quick way after we use point slope form, just so I can show you how to use it if you haven't used it before. Okay, so like I said, we use point slope form when we're given a slope, so our slope is going to be 1/2, and some point x1 comma y1. So here's x1 and here's y1. So if we're going to substitute this stuff into our formula, notice that we're going to leave the x alone and we're going to leave the y alone, because those are our variables that we need to stay as variables in order to get the equation of the line. So we're only going to plug in stuff for m, x sub 1, and y sub 1, which is the information that we had identified over here. So y minus y1, notice it's a negative 4. So minus negative 4 equals slope of 1/2, x minus x1, which is 0. So we have y on the left-hand side plus 4 equals 1/2 x minus 0, so we don't really care about that 0 anymore. The last step is just to subtract the 4 over from both sides. So I get that the equation of this line is y equals 1/2 x minus 4. Okay, If you hear that loud noise, sorry, there's maintenance going on outside. Now go ahead and if you did it this way, ask yourself if there was a quicker way, and maybe you'll notice the relationship between the information we have here and the stuff provided at the beginning of the problem. And some of you might have already caught it, but if you haven't, maybe take a quick second, pause the video. Do you notice some similarities between the information we were given and the equation we ended up with? Okay, hopefully you found that all along we were given the y-intercept, right? Over here you were told exactly, hey, this is the y-intercept. But over here I didn't really tell you that directly. Okay, it's important for you to be able to important for you to be able to identify that when I say this, y-intercept of whatever the value is, that's the same thing as saying I could have said this instead passes through 0, 2, because those are the same thing. Not these two examples, but like the way that you word those two. Passes through 0, -4, I might as well have just said y-intercept of -4. But I want you to be able to remember, maybe you don't really remember that from Algebra 1, but I want to make sure that you have that fresh in your mind. Y-intercept means that our x value for the ordered pair is 0, and vice versa. When you have an x-intercept, you have a value for the x-coordinate, but our y-coordinate is 0. Okay? So then part B, I could have done exactly like part A. Notice that my slope is 1/2 and my y-intercept is -4, so I could have just written it out directly. Y equals 1/2 x minus 4. Now let's do a couple where that's not going to fly. Part C. Okay, part C passes through 5, 4 and has a slope of 3. I can't do that same trick because this is not a y-intercept. So no matter what, I'm going to have to use point slope form here. Okay, so now that we know that that's the only way, let's go ahead and try it. Y minus, we can identify our parts really quick. This is our x1, y1, m. Y minus 4 equals 3, x minus 5. Okay, if you want to, go ahead and pause the video and work that out really quick. See if you can, sorry, there was a little piece of eraser. See if you can simplify all the way on your own. Okay, pause it, and then if you get to the answer, you can go ahead and see if we got the same thing. Okay, so y minus 4 equals, I need to distribute this 3, multiply it to my x, and multiply it to my minus 5. 3x minus 15. Okay, what's my last step? I need to get y by itself for a slope-intercept form. Now, sometimes if the question asks you to just leave the equation of the line in point-slope form, this right here would have been your answer. This is our point-slope form. Okay, so if I ever ask you to give me the equation of the line in point-slope form, here's where you would stop. Okay? So if I put that on a checkpoint on a Friday, make sure you're comfortable with that, right? Because sometimes I might ask you to go all the way to slope-intercept. Sometimes I might just ask you to stop at point-slope, okay? So then to solve for y, we just got to add 4 to both sides. What do we end up with? We get y is equal to 3x negative 15 plus 4 minus 11. Sorry, negative 11. So this is the equation of our line. Okay. Notice how there is no relationship right now between this y-intercept and the point I was provided. Okay. So that's kind of why you have to be careful. We can use that not shortcut, but that little that thing that we noticed. We can use that here because this is exactly a y-intercept, but this is not a y-intercept because our x value is not 0. Okay. One more example, and then I'm going to have you try, one more example together, and then I'm going to have you try one on your own, okay? Passes through -1, 3 and 2, 9. Okay, so this is different from the ones that we've done so far. In part A, I gave you a slope and a y-intercept. In part B, same thing, I gave you a y-intercept and a slope. I just disguised the y-intercept a little bit. And then part C, I gave you a point and a slope. Here I'm giving you 2 points. we don't have an equation or a form of equation for that just yet. We kind of do. We just don't have a piece of information that we desperately need, which is our slope. But luckily in 2.2, you found slope. You did plenty of practice problems finding slope. So that's the first step here. We got to find our slope. Let's do that. M is equal to 9 minus 3 divided by 2 minus negative 1. 9 minus 3 is 6. 2 plus 1 is 3. Our slope is 2. M is equal to 2. Okay, so now we can use point-slope form. We're given 2 points, okay? Don't let that freak you out though. You can choose whichever one you want to. Why are we allowed to choose whichever one we want to? Well, maybe pause the video and maybe think about that question really quick. Why? I'm telling you that that's correct. I'm allowed to use whichever point I want in order to find the equation of this line. But maybe ask yourself, why is that the case? Why am I allowed to use either one? Okay. If you're having trouble thinking about that, well, think about what we're trying to do here. We're taking these 2 points, and eventually, if we were to graph those two, there is going to be a line that crosses those 2 points. Well, we just said a line is going to cross those 2 points. If they're on the same line, then of course point slope is going to work. Because why would one point give me a different equation than the other if they're both on the same line? Okay, I have to be able to plug in -1 for x and 3 for y and get equality, otherwise these aren't even on the line to begin with. Okay, just a little bit of thinking about, why is it that we're doing the things that we do in math, right? So pick your favorite. I'm going to pick 2, 9. Y minus 9 is equal to 2x minus 2. Simplify as you have been. Distribute our 2. Y minus 9 is equal to 2x minus 4. Add the 9 over. -4 plus 9. Well, that's going to be 5. And here is the equation of our line. Okay, hopefully that makes sense to you. Now, go ahead and give this one a shot. Okay, we want to find the equation of the line in slope-intercept form that passes through -8, 20 and -6, 15. Give that a shot, and once you're done, meet me in the next video.